Astronomers have long suspected that the early universe was not as simple and chaotic as the textbooks describe. Now, the James Webb Space Telescope has confirmed those suspicions in a way few expected. Hidden in the faint glow of the universe's first billion years, Webb has uncovered galaxies so old, so luminous, and so chemically evolved that they rewrite the story of how cosmic structure emerged. What was once thought to be an age of scattered gas and slow beginnings now appears to have been a time of rapid creation and astonishing order. When Hubble set the record in 2016 with GNZ11, a galaxy whose light had traveled over 13 billion years, it seemed like the outermost edge of possibility. But Webb's powerful infrared vision quickly broke that boundary. Within months of its first deep surveys, Webb revealed galaxies with redshifts beyond 14, peering back to just a few 100 million years after the Big Bang. Among them was a compact galaxy only 500 light-years across, burning with the light of countless newborn stars. It wasn't faint, primitive, or chemically barren as models predicted. It was dazzling, structured, and enriched with elements that should not have existed so early. The real shock came in the spectrum. Webb detected high levels of nitrogen, a chemical marker that should only appear after multiple generations of stars live, explode, and seed their surroundings with heavy elements. This meant that by the time this tiny galaxy formed, entire cycles of stellar birth and death had already occurred. The universe wasn't just forming its first stars in those early centuries. It had already matured enough to recycle them, reshaping the cosmic timeline by hundreds of millions of years. Even stranger was what Webb didn't find. Galaxies of such brilliance almost always conceal a supermassive black hole at their core, the gravitational engine thought to regulate growth and star formation. But this ancient galaxy showed no signs of one. No telltale X-ray glow, no accretion, no distortion in its structure. It seemed to thrive without the very mechanism astrophysicists believed essential. Either black holes weren't necessary in the first stages of galaxy building, or Webb had caught this object in a fleeting moment before one came into existence. At first, astronomers considered it an outlier, a cosmic accident. But as Webb's surveys expanded, more galaxies like it began to appear. Dozens of compact, brilliant islands of stars emerged from the darkness of the early universe, each one breaking another rule. Some were even more chemically rich, suggesting a history older and more complex than our models allowed. The picture forming was not of a quiet, gradual beginning, but of a universe that leapt into complexity almost as soon as it was born. The implications are profound. Our simulations of the early cosmos assume slow star formation, simple chemistry, and galaxies built patiently over eons. Webb is showing us something very different: rapid stellar growth, heavy element enrichment in record time, and a cosmos that seemed to prefer structure over chaos from the very start. It may mean that what we call the beginning was not the true dawn of order, but the aftermath of an even earlier, hidden phase of cosmic evolution. With every deep field Webb captures, that hidden chapter grows harder to ignore. The first billion years of the universe are being rewritten, not as a silent, empty stretch of darkness, but as a dazzling storm of creation. And the deeper Webb looks, the more it seems we are only now glimpsing the real story of how everything began. Astronomers have long carried the suspicion that the universe's first moments of structure and light were not as simple as our models suggest. The James Webb Space Telescope is now providing evidence that these doubts were justified. Its deep surveys are revealing galaxies that appear too evolved, too organized, and too chemically enriched for their age. And as new findings emerge, other anomalies across cosmology are beginning to connect with Webb's discoveries in unsettling ways. One such anomaly comes from galactic spin. In an isotropic universe, the direction of rotation should be nearly random, split between clockwise and counterclockwise. Yet surveys suggest a preference, a faint but persistent pattern of galaxies turning the same way. This coherence hints at a large-scale order, a kind of cosmic handwriting etched into the fabric of spacetime itself. Combined with Webb's glimpses of galaxies forming stars with incredible speed and efficiency, the question arises: was the early universe not only active but deliberately structured? The implications grow even stranger. A number of physicists are revisiting the bold hypothesis that our universe could be the interior of a black hole. In this view, the Big Bang was not the birth of all things but the rebound from a collapse in a larger parent cosmos. This framework could explain why the laws of physics seem so finely tuned for stability and life. It could also account for the surprising degree of order appearing in Webb's early galaxy data. If every black hole spawns a new universe with its own constants, then only those universes capable of sustaining complexity endure. By that logic, the apparent precision in cosmic structure may not be an accident, but the result of deep evolutionary selection. And then there is a still more unsettling interpretation. Some researchers propose that what Webb is uncovering may point toward a universe that is not merely evolving, but self-organizing on the grandest scale. The coordinated galactic spins, the improbable chemical enrichment, the rapid march toward complexity, these may not be random coincidences, but the signature of a system aware of its own unfolding. In this perspective, the universe is not indifferent. It participates in its own growth. Stars, galaxies, and even conscious beings become feedback nodes in a vast loop of cosmic self-discovery. What Webb has revealed so far is only the beginning. Galaxies forming impossibly fast, structures enriched long before they should exist, patterns that suggest coherence where chaos was expected. All of these findings point toward a cosmos far richer and more ordered than we imagined. If the early universe was already steeped in complexity, then the origins of matter, structure, and perhaps even life may trace back to forces or principles beyond our present science. The telescope has not just expanded our vision of space, it has cracked open questions long avoided. Was the cosmos shaped by hidden laws we have yet to uncover? Do we inhabit the interior of a larger reality? Could the universe itself be aware in ways we are only beginning to suspect? These are not the dreams of speculation anymore, they are questions demanded by evidence. And as Webb continues to peer deeper into the first light of creation, we may find that the universe is not only stranger than we thought, but also far more purposeful.